Polynomials, the factor theorem. Let's look at the factor theorem. If we have function of x is equal to x cubed minus 5x squared plus 3x plus 6, we can show by expanding the brackets that x minus 2 into x squared minus 3x minus 3 is equal to function of x. So we see that x minus 2 is a factor of the cubic polynomial. If we substitute x equals 2 in function of x, we get the bracket x minus 2 is 0, so the function of x is 0 times x squared minus 3x minus 3, which is 0. So the function of 2 is 0. This tells us that x equals 2 is a root of the equation function of x equals 0. In general, if x minus a is a factor of a polynomial g of x, then substituting x equals a makes g of a equals 0. So x equals a is a root of the polynomial. Now the factor theorem states that if function of x is a polynomial and if function of a equals 0, then x minus a is a factor of function of x. Also, if x minus a is a factor of function of x, then function of a equals 0, and x equals a is a root of the equation function of x equals 0. This can be very useful when factorizing polynomials. Just as a side point, note, if a polynomial has order n, then it has at most n factors. So let's have a look at an example. Factorize x cubed plus 2x squared minus 5x minus 6. To solve this, since the last number is 6, which has factors 1, 2, 3 and 6, it's worth trying x equals plus or minus 1, x equals plus or minus 2, x equals plus or minus 3, and x equals plus or minus 6. So working them out, function of 1 is equal to 1 cubed plus 2 times 1 squared minus 5 times 1 minus 6, which equals minus 8. Function of 2 is equal to 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6, which equals 0. Now that tells us x minus 2 is a factor. If we try function of 3, we get 3 cubed plus 2 times 3 squared minus 5 times 3 minus 6, which comes out to 24. If we try function of 6, 6 cubed plus 2 times 6 squared minus 5 times 6 minus 6 is 252. Function of minus 1 is minus 1 cubed plus 2 times minus 1 squared minus 5 times minus 1 minus 6, which is minus 1 plus 2 plus 5 minus 6, which is 0. So x plus 1 is a factor. Function of minus 2 is minus 2 cubed plus 2 times minus 2 squared minus 5 times minus 2 minus 6, which is minus 8 plus 10 minus 6, which is 4. Function of minus 3 is minus 3 cubed plus 2 times minus 3 squared minus 5 times minus 3 minus 6, which is minus 27 plus 18 plus 15 minus 6, which equals 0. So x plus 3 is a factor. And function of minus 6 is minus 6 cubed plus 2 times minus 6 squared minus 5 times minus 6 minus 6, which is minus 216 plus 72 plus 30 minus 6, which is minus 120. So we got a 0 for function of 2, function of minus 1, and function of minus 3. So the factors are x minus 2, x plus 1, and x plus 3. So x cubed plus 2x squared minus 5x minus 6 factorizes as x minus 2 into x plus 1 into x plus 3. Let's look at another example. write down a cubic equation which has roots x equals 3, x equals minus 4, and x equals 5. Well, to do this, the equation has factors x minus 3, x plus 4, and x minus 5. So the equation is x minus 3 into x plus 4 into x minus 5 equals 0. Now we can expand the second pair of factors to give us x minus 3 into x squared minus 5x plus 4x minus 20 equals 0, which simplifies to x minus 3 into x squared minus x minus 20 equals 0. Now if we multiply out, that gives us x cubed minus x squared minus 20x, and then multiplying by minus 3, minus 3x squared plus 3x plus 60 equals 0. And that gives us x cubed minus 4x squared minus 17x plus 60 equals 0. Now, if we have a cubic equation, it's often best to find one factor, divide, and then factorize the quadratic. So, for example, factorize 3x cubed plus 5x squared minus 11x plus 3. If we try x equals 1, function of 1 equals 3 times 1 cubed plus 5 times 1 squared minus 11 times 1 plus 3, which is equal to 3 plus 5 minus 11 plus 3, which is 0. So x minus 1 is a factor. Now if we do the division sum, we start by dividing 3x cubed by x. And that gives us 3x squared, which we write on the top in the x squared column. We now multiply 3x squared times x minus 1, and that gives us 3x cubed minus 3x squared. We subtract 3x cubed, take away 3x cubed leaves nothing. 5x squared, take away minus 3x squared is 8x squared. We bring down the minus 11x. And we divide again, x into 8x squared. Well, that's 8x. We write that on the top in the x column. We now multiply 8x times x minus 1. That gives us 8x squared minus 8x, which we subtract. The x squareds cancel out, and we have minus 11x take away minus 8x, which is minus 11x plus 8x, which is minus 3x. We bring down the plus 3, and we say x into minus 3x. That's minus 3, so we multiply minus 3 times x minus 1 to get minus 3x plus 3. We take away, and that leaves remainder 0. We now try to factorize 3x squared plus 8x minus 3. Now this is slightly harder because it's got a number in front of the x squared. So we look for two numbers that have a sum of 8 and a product of 3 times minus 3, or minus 9. Now those two numbers are 9 and minus 1. So we split up the middle term, the 8x, into 9x minus 1x. That gives us 3x squared plus 9x minus 1x minus 3. We can factorize the first pair of terms as 3x into x plus 3, and we can factorize the second pair of terms as minus 1 into x plus 3. So we have x plus 3 coming twice. We've got 3x times x plus 3 minus 1 times x plus 3, so we have 3x minus 1 times x plus 3. So our original polynomial, 3x cubed plus 5x squared minus 11x plus 3, factorizes as x minus 1 into 3x minus 1 into x plus 3. If we look at a fourth example, solve x cubed minus 7x squared plus 12x minus 4 equals 0. We have function of x equals x cubed minus 7x squared plus 12x minus 4. Then function of 1 is 1 cubed minus 7 times 1 squared plus 12 times 1 minus 4, which works out to be 2. Function of 2 is equal to 2 cubed minus 7 times 2 squared plus 12 times 2 minus 4, which is 8 minus 28 plus 24 minus 4, which equals 0. So x equals 2 is a root of the equation, or x minus 2 is a factor of function of x. Now that means x minus 2 can be divided exactly into the original cubic equation. So if we set it out as a division sum, we start x into x cubed is x squared. Write x squared on the top in the x squared column. X squared times x minus 2 is x cubed minus 2x squared. If we subtract, that gives us minus 5x squared. And we can bring down the plus 12x. Now we do x into minus 5x squared goes minus 5x. We multiply minus 5x with x minus 2, and that gives us minus 5x squared plus 10x. Now if we subtract, we're left with just 2x. We can bring down the minus 4 and divide x into plus 2x. Well, that's just plus 2. We multiply the plus 2 with the x minus 2, and that gives us 2x minus 4. When we subtract, we get 0, so there's no remainder. So we know x equals 2 is one root. Now we need to find the roots of the quadratic. Now that doesn't actually factorize as whole numbers, so we're going to have to use the formula x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And we have a is 1, b is minus 5, c is equal to 2. So substituting those numbers in and simplifying, we get x is equal to 5 plus or minus the square root of 25 minus 8 over 2, or x equals 5 plus or minus root 17 over 2. Now we could either leave it like that, or if we want to, we can use a calculator to work out the square root of 17. X is equal to 5 plus or minus 4.12311 all over 2. So x is equal to 4.56155, or x equals 0.43845. So our final answer is x is equal to 2, and x is equal to 5 plus root 17 all over 2, or x is equal to 5 minus root 17 over 2. Or we could write that in numbers, x equals 2, or x equals 4.562, or x equals 0.438. Now, we have an exercise. You can pause the video at this point and have a go at them yourself. Then when you've tried them, you can restart the video and I'll go through the solutions. Okay, in question 1a we've got x cubed minus 2x squared minus x plus 2. Now because the last number is 2, we could try substituting x equals plus or minus 1 or x equals plus or minus 2. So if x is 1, we have 1 cubed minus 2 times 1 squared minus 1 plus 2, which is 1 minus 2 minus 1 plus 2, which is 0. So x minus 1 is a factor. If we try x equals minus 1, we get minus 1 cubed minus 2 times minus 1 squared minus minus 1 plus 2, which is minus 1 minus 2 plus 1 plus 2, which is 0. So x plus 1 is a factor. If we try x is 2, we get 2 cubed minus 2 times 2 squared minus 2 plus 2, which is 8 minus 8 minus 2 plus 2, which is again 0, and so x minus 2 is a factor. So the factors are x minus 1, x plus 1, and x minus 2. So the answer is x minus 1 into x plus 1 into x minus 2. In 1b, we have the final number is 6. So it's worth trying substituting x is equal to plus or minus 1, x is equal to plus or minus 2, x is equal to plus or minus 3, and perhaps x equals plus or minus 6. If we try x equals 1, we have 1 cubed minus 2 times 1 squared minus 5 times 1 plus 6, which is 1 minus 2 minus 5 plus 6, which is 0. If we try x is equal to minus 1, we get minus 1 cubed minus 2 times minus 1 squared minus 5 times minus 1 plus 6, which is minus 1 minus 2 plus 5 plus 6, which equals 8. If we try x equals 2, we get 2 cubed minus 2 times 2 squared minus 5 times 2 plus 6, which is 8 minus 8 minus 10 plus 6, which is minus 4. If x is minus 2, we get minus 2 cubed minus 2 times minus 2 squared minus 5 times minus 2 plus 6, which is minus 8 plus 10 plus 6, which is 0. If we try x equals 3, we get 3 cubed minus 2 times 3 squared minus 5 times 3 plus 6, which is 27 minus 18 minus 15 plus 6, which is 0. So we got 0 when x is equal to 1, x is equal to minus 2, and x is equal to 3. So the factors are x minus 1, x plus 2, and x minus 3. So the original factorizes as x minus 1 into x plus 2 into x minus 3. In part C, we want to factorize x cubed plus 5x squared minus x minus 5. Since the last number is 5 and has factors 1 and 5, we should try substituting x is plus or minus 1 and x is plus or minus 5. So if x is equal to 1, we have 1 cubed plus 5 times 1 squared minus 1 minus 5, which is 1 plus 5 minus 1 minus 5, which is 0. If x is minus 1, we have minus 1 cubed plus 5 times minus 1 squared minus minus 1 minus 5. That is minus 1 plus 5 plus 1 minus 5, which is 0. If x is 5, we have 5 cubed plus 5 times 5 squared minus 5 minus 5, which is 125 plus 125 minus 5 minus 5, which is 240. If x is minus 5, we have minus 5 cubed plus 5 times minus 5 squared minus minus 5 minus 5, which is minus 125 plus 125 plus 5 minus 5, which is equal to 0. So the polynomial is 0 when x is equal to 1, x is equal to minus 1, and x is equal to minus 5. So the factors are x minus 1, x plus 1, and x plus 5. So the original cubic factorizes as x minus 1 into x plus 1 into x plus 5. In part D, we have x cubed minus 6x squared minus 9x plus 14. Since it ends in 14, we should try x equals plus or minus 1, x equals plus or minus 2, x equals plus or minus 7, and perhaps x equals plus or minus 14. If we try x equals 1, we have 1 cubed minus 6 times 1 squared minus 9 times 1 plus 14, which equals 1 minus 6 minus 9 plus 14, which is equal to 0. If x equals minus 1, we have minus 1 cubed minus 6 times minus 1 squared minus 9 times minus 1 plus 14, which is minus 1 minus 6 plus 9 plus 14, or 16. If x equals 2, we have 2 cubed minus 6 times 2 squared minus 9 times 2 plus 14, which is 8 minus 24 minus 18 plus 14, which equals minus 20. If x is minus 2, we have minus 2 cubed minus 6 times minus 2 squared minus 9 times minus 2 plus 14, which is minus 8 minus 24 plus 18 plus 14, which equals 0. If x equals 7, we have 7 cubed minus 6 times 7 squared minus 9 times 7 plus 14, which is equal to 343 minus 294 minus 63 plus 14, which equals 0. So we have 0 when x equals 1, when x equals minus 2, and when x equals 7. So the factors are x minus 1, x plus 2, and x minus 7. So when we factorise the cubic, we get x minus 1 into x plus 2 into x minus 7. In question 2, we'll try finding one root and then using the quadratic formula to solve them. So, in question A, we have x cubed minus 8x squared plus 18x minus 9. If we try x equals 1, we get 1 cubed minus 8 times 1 squared plus 18 times 1 minus 9, which is 1 minus 8 plus 18 minus 9, which is 2. If we try x equals minus 1, we get minus 1 cubed minus 8 times minus 1 squared plus 18 times minus 1 minus 9, which is minus 1 minus 8 minus 18 minus 9, which is minus 36. If we try x is equal to 3, we get 3 cubed minus 8 times 3 squared plus 18 times 3 minus 9, which gives us 27 minus 72 plus 54 minus 9, which is 0, which means x minus 3 is a factor. Now we can do a division sum, x minus 3 into the original cubic, and we start x into x cubed is x squared. We write that on the top in the x squared column. Now we multiply x squared times x minus 3, and that gives us x cubed minus 3x squared. When we subtract, we've got minus 8x squared, take away minus 3x squared, which is minus 8x squared plus 3x squared, or minus 5x squared. We bring down the 18x, and we divide x into minus 5x squared. Now that goes minus 5x. We write that on the top in the x column. Now we multiply minus 5x times x minus 3, and that gives us minus 5x squared plus 15x, so that when we subtract, we're left with 3x. We bring down the next number, which is minus 9, and divide x into 3x. Now that goes plus 3 times. We multiply the plus 3 with the x minus 3, and we get 3x minus 9, so when we subtract we get 0. So we already have one root, x equals 3, and we can use the quadratic formula to find the other root. We need to substitute in a is 1, b is minus 5, and c is 3. We put that in the quadratic formula, and that simplifies to 5 plus or minus the square root of 25 minus 12 all over 2, which gives us x is equal to 5 plus or minus root 13 over 2. Now we can leave those as our answers, or we can, using a calculator, work out the square root of 13. This gives us x is equal to 5 plus or minus 3.60555 divided by 2. So x is equal to 4.30278, or x is equal to 0.69722. So our roots are 3, 4.303 and 0.697, Or if we want to leave it in third form, the roots are 3, 5 plus root 13 over 2, and 5 minus root 13 over 2. In 2 part B, we have x cubed minus 7x squared plus 11x minus 2 equals 0. Now that ends in minus 2, so it's worth trying x equals plus or minus 1 or x equals plus or minus 2. If we try x equals 1, we get 1 cubed minus 7 times 1 squared plus 11 times 1 minus 2, which is 1 minus 7 plus 11 minus 2, which is 3. If you try x equals minus 1, we get minus 1 cubed minus 7 times minus 1 squared plus 11 times minus 1 minus 2, which gives us minus 1 minus 7 minus 11 minus 2, which gives us minus 21. If we try x equals 2, we get 2 cubed minus 7 times 2 squared plus 11 times 2 minus 2. That is 8 minus 28 plus 22 minus 2, which is equal to 0. So we can say x minus 2 is a factor. So dividing, we start with x into x cubed, which is x squared. We write that on the top in the x squared column. X squared times x minus 2 is x cubed minus 2x squared. If we subtract, that gives us minus 5x squared. We bring down the plus 11x and divide x into minus 5x squared. That gives us minus 5x, and we multiply minus 5x with x minus 2. That gives us minus 5x squared plus 10x, and when we subtract, that leaves 1x. And when we bring down the minus 2, we have 1x minus 2. We divide x into 1x, that's plus 1. 1 times x minus 2 is x minus 2, and when we subtract, that leaves 0. So, one factor is x minus 2, and we need to solve x squared minus 5x plus 1. Now we can use the quadratic formula, substituting a is 1, b is minus 5, and c is 1. Now that simplifies down to x equals 5 plus or minus the square root of 25 minus 4 over 2, or x equals 5 plus or minus root 21 over 2. We can write that as x equals 5 plus or minus 4.58258 all over 2, to give us the roots x equals 4.79129 or x equals 0.20871. So the roots are 2, 4.791 and 0.287, or if we want to leave it in third form, the roots are 2, 5 plus root 21 over 2 and 5 minus root 21 all over 2. In question 3, we want to solve the simultaneous equations y equals x cubed minus 5x squared plus 6x and y equals x minus 2. Well, we can do this by equating the two y terms, and that gives us x cubed minus 5x squared plus 6x equals x minus 2, which can be rearranged as x cubed minus 5x squared plus 5x plus 2 equals 0. Now, it ends in plus 2, so let's try x is plus or minus 1 or x is plus or minus 2. If x is 1, we have 1 cubed minus 5 times 1 squared plus 5 times 1 plus 2, and that works out to be 3. If x is minus 1, we've got minus 1 cubed minus 5 times minus 1 squared plus 5 times minus 1 plus 2, and that works out to be minus 9. If we try x is equal to 2, then we have 2 cubed minus 5 times 2 squared plus 5 times 2 plus 2, which is 8 minus 20 plus 10 plus 2, which equals 0. So we know x minus 2 is a factor. That means we can divide by x minus 2. And to do this, we do x into x cubed, which is x squared. We multiply by x squared. X squared times x minus 2 is x cubed minus 2x squared. We subtract, and that leaves minus 3x squared. Then we bring down the 5x. We divide x into minus 3x squared, which gives us minus 3x. Minus 3x times x minus 2 is minus 3x squared plus 6x. When we subtract, that leaves us minus 1x. We bring down the plus 2, and we divide x into minus 1x. That gives us minus 1. We multiply minus 1 times x minus 2 is minus 1x plus 2, and when we subtract, that's 0. So we now want to find the roots of x squared minus 3x minus 1. And we can use the quadratic formula, substituting a is equal to 1, b is minus 3, and c is minus 1. Now, that simplifies to x equals 3 plus or minus root 9 plus 4 over 2, or x equals 3 plus or minus root 13 over 2, which means x is equal to 3 plus or minus 3.60555 all over 2, or x is equal to 3.303 or minus 0.303. Now, y is equal to x minus 2, so if x is equal to 2, then y is 0. If x is equal to 3.303, then y is equal to 1.303. And if x is equal to minus 0.303, then y is equal to minus 2.303. So our solutions are x equals 2 and y equals 0, or x equals 3.303 and y equals 1.303, or x equals minus 0.303 and y equals minus 2.303. Now we can draw this on a graph. We can draw the cubic equation and then the linear equation and see where they intersect. And we see that they do intersect at x is 2, y is 0, and also at x is equal to 3.3 and y is equal to 1.3, or x is equal to minus 0.3 and y equals minus 2.3.